Heat guns are commonly in use for various tasks such as paint stripping, plastic welding, thawing frozen pipes, and heat-shrinking tubing. However, like any tool, heat guns can encounter issues that affect their performance, safety, and lifespan. This video explores common problems with heat guns and provides advice on avoiding these problems, plus tips for extending their life. What are some of the common problems with heat guns? Overheating is one of the most common issues with heat guns. It occurs when the tool is used for long periods without breaks or when it operates at high temperatures continuously. Overheating can damage internal components like the heating element, motor and circuit boards. What causes overheating? Prolonged use without allowing the gun to cool. Operating at maximum temperature settings for extended periods. Blocked air vents, reducing airflow and increasing internal temperature. The consequences of overheating include shortened tool lifespan, potential for the tool to malfunction or become a fire hazard, as well as possible damage to the material being worked on due to excessive heat. Nozzle blockages are another frequent issue with heat guns. The nozzle can become clogged with debris, especially in dirty or dusty environments, which restricts airflow and causes the tool to overheat. What are some of the causes of nozzle blockage? Accumulation of dust, paint, or other particles. Using the heat gun in particulate-rich environments. Melting substances that harden and block the nozzle. The consequences of blocked nozzles include reduced airflow and heat output, increased risk of overheating, and inconsistent performance during operation. The heating element is the core of the heat gun, generating the high temperatures required for various tasks. Over time, especially with improper use, the heating element can burn out, making the tool unusable until repaired or replaced. What causes burnt-out heating element? Continuous use at maximum temperature settings, insufficient cooling periods between uses, power surges, or using an inappropriate power supply. The consequences of a burnt-out heating element are a complete loss of functionality, as well as downtime while the tool is repaired or replaced. The fan in a heat gun is essential for evenly distributing heated air and cooling the tool's internal components. If the fan fails, the heat gun can overheat quickly, leading to compromised airflow and inconsistent performance. What causes fan failure? Physical obstruction of the fan by debris, mechanical wear over time, operating in a dirty or dusty environment without regular cleaning. The consequences of such failure includes inadequate cooling leading to overheating, plus reduced efficiency and inconsistent heat distribution. Having looked at the common issues, now let's look at how to extend the use of your heat gun. To maximize the lifespan of your heat gun, it's crucial to follow best practices in usage and maintenance. The following tips will help you avoid common problems and keep your tool in top condition. Regular maintenance. Routine maintenance is vital for extending the life of your heat gun. This includes cleaning the nozzle and air vents, checking the power cord for damage, and inspecting the tool for wear and tear. Cleaning. Regularly remove debris or dust from the nozzle and vents using a soft brush or compressed air. Inspection. Check the power cord for signs of fraying or damage, and inspect the casing and switches to ensure they are in good condition. Proper usage. Using the heat gun correctly is key to preventing premature failure. Avoid running the tool at maximum temperature settings for prolonged periods and always let the gun cool down before storing it. Temperature control. Use the appropriate temperature setting for each task. For example, low to medium settings are often sufficient for drying paint or thawing pipes. Cool down periods. Allow the heat gun to cool down after every 15 to 20 minutes of use to prevent overheating and reduce wear on internal components. Avoid blockages. Keep the nozzle and vents clear of obstructions to ensure adequate airflow, which is essential for maintaining consistent temperature and preventing overheating. Environment. Use the heat gun in a clean environment when possible. If you must work in dusty or dirty areas, clean the tool regularly to prevent blockages. Material handling. Be cautious with materials that could melt and harden inside the nozzle as they can cause blockages. Safe storage. Store your heat gun in a cool, dry place, away from dust, moisture, and direct sunlight. Proper storage helps prevent electrical issues, corrosion, and damage to the tool's components. Cooling before store always. Let the heat gun cool down completely before storing it to prevent heat damage and reduce fire risk. Avoid areas with extreme temperatures, such as near windows or in garages. Use appropriate accessories. Using the correct nozzles and attachments for specific tasks can reduce strain on the heat gun and improve its efficiency. Different nozzles are designed for various applications, such as focused heating, wide area heating, or deflecting heat from sensitive areas. In conclusion, it is important to reiterate that heat guns are incredibly useful tools, but they require proper care and usage to avoid the common problems discussed.